So in today's session, I want to talk about how can we remove the node from double linked list. So how can we remove the node from double linked list? Okay. See here already double linked list is created. Already double linked list is created. Okay. Now this is a double linked list. This double linked list has elements like 10, 20, 30, 40, 50. So this linked list, this double linked list already created. First node name is first, last node name is last. So this linked list already created. Okay, so already linked list is created. Okay, I'm printing linked list elements. This linked list is created. Observe here, linked list elements are 10, 20, 30, 40, 50. So linked list is already created. Linked list created. So elements are 10, 20, 30, 40, 50. So now I want to remove the node. I want to remove the element from the linked list. So here three cases are there. First case is removing first node. Second case is removing last node. Third case is removing middle node. Okay, so three cases are there. So what is the topic name? Removing node from the linear double linked list. Removing node from the linear double linked list. Observe here. See. So removing node from the linear double linked list. Removing node from the linear double linked list. So how can we remove? Okay, so here three cases are there. Three cases are there. What are those three cases? First one is removing first positions node. Okay, at first position, removing the node which is in first position. Okay, removing the node which is in last position. Okay, removing middle node. Removing middle node. So removing the node which is at first position, removing the node at last position, last position, removing middle node. Okay, so three cases are there. Now see the first case at first position. So if you want to remove the first position node, we call like this. We call like L1 dot remove. We give the position value as 1. So here we are calling which method? Remove method. We are passing position value. So define remove method now. Define remove method. Take one integer type argument. I'm capturing the position in the p variable. I don't want to return any value, so I'm writing return type as white. So this method I want to define now. For removing the node, I'm defining this method. Okay. So now check whether the position value is 1 or not. So if position value is 1, position value 1 means we are removing first node. Here position value is 1 means we are removing first node. Observe carefully here. So directly I'm writing in our program. So here I'm adding one method. Here I'm adding one method. Observe. So method name I'm giving as remove. Remove is the method name. So to capture the position value, I'm taking p variable here. Okay, so now check whether the position value is 1 or not. To check position value is 1 or not, I'm writing if p equals to 1. This condition true means we are removing first node. Observe carefully here. Observe the image. So we want to remove the first node. So we want to remove this node. We want to remove this node. First positions node. Okay. So assume this as the temp now. Assume this as the temp. So what we write? Temp equals to first. So write temp equals to first. Temp equals to first. Okay. Then what we have to do is, so you are removing first node. So this is first. This one is what? First next. This is first means this one is what? First next. Okay. So first we want to remove now. If we remove first node, this first next should become the first node. So this is first next. So make this first next as the first node. So to make first node as the first next as the first node, to make first next as the first node, what we write? First equals to first next. So first next becomes the first node. First node removed means first next will become first next means second. Second node will become the first node. We are removing first node means okay. So second node will become the first node. So second node is what? First next. So first next is the second node. So first next we are making as first node. That's it. Okay. So now this is first. This is first next. So we are making first next as the first. So now this one is the first. So this one first means this one is not first. No, this one is not first. This one is not first. Okay. So before this, no node is there. So we are removing this node means so first previous no node is there. So store first previous value as null. So here I want to store null. Here I want to store null. Okay. Now these links will not be there. Okay. This link will be removed now. This link will be removed. Okay, first previous value is what? Null. So here this is the previous, this one is the previous, this one is the x, this one is the next. So first previous value I want to change now. First previous equals to null. So right here first previous equals to null. First previous equals to null. Observe here. Okay, so we are removing the first node. So first node removed. Okay, so first node remove. Observe, I'm removing this. I'm removing this. Okay. Now observe, this one is the first node, this one is the last node. So this node is removed. First position node is removed. Okay. So finally, to in C++, automatic memory management is not there. Okay, so we have to destroy the memory. So to delete this node, we assumed this node as temp. So we have to delete the temp. So to destroy the memory, we use delete operator. So write delete temp here. So we are deleting the temp. Temp means what? First. So first node we are deleting here. So if position value is 1, okay, we are deleting the temp. We are assuming we first address coming into the temp. So the temp we are removing here. So now first next is becoming first. So first previous no node is there. We are making that as a null. That's it. So this is deleting node at first position. Else. So when that comes to this else block, if position value is not 1, that comes to this else block. Okay. Please all of you be in mute mode. Okay. See here. Listen. See, for example, I am giving position value as next at last position. At last position, I want to insert. I want to insert at last position. So if you want to insert at last position, we call like this: L1 dot remove. So how many nodes are there? 5 nodes are there. I want to remove the 5th node, last node. Okay, so I'm giving position value as 5. Okay, I'm opening fresh file here. Just a minute. See. Now I want to delete this last node. I'm giving position value as 5. Okay, so which node we have to remove now? This last node we have to remove. So this node I want to remove now. This node I want to remove. Okay, so how we are calling? We are calling like L1 dot remove. We are giving position value as 5. So 5 means this 5th node we have to remove. So to remove this 5th node, we have to come up to the position 4. We have to come up to the position 4. So for that, assume this one as first. Assume this first one as pointer. So if this is pointer, this one is what? Pointer next. So make pointer next as a pointer for first time. Okay, then if this is the pointer, this one is the pointer next. So make pointer next as a pointer for second time. So this is pointer means this is pointer next. Make pointer next as a pointer. Okay, for third time. We are giving position value 5 means 3 times pointer next is becoming pointer. So first time we are assuming first as a pointer. Make this pointer next as a pointer first time. Make this pointer next as a pointer second time. Make this pointer next as a pointer third time. We are giving position value as 5, means 3 times p minus 2 times we have to execute. So that code I'm writing. So right here, assume assume first node as the pointer. So write pointer equals to first. So make pointer next as the pointer. So for that, write pointer equals to pointer next. So we are making pointer next as a pointer. For how many times it has to execute this statement? For p minus 2 times. So right, for int I equals to 1, I less than or equals to p minus 2, I plus plus. Okay, so this statement will get executed for p minus 2 times. So now we are here. This one is a pointer. So this one pointer means these are not pointers. No, these are not pointers. These are not pointers. Okay. So now see here. Observe. So now this one is a pointer. If this one is a pointer, this one is what? Pointer next. Okay. So this one is the pointer. This one is what? Pointer next. Okay. So here, check. I want to check this one. So this is what? Previous. This one is what? X. This one is what? Next. Okay. Observe carefully here. Observe carefully. Just a minute. Just a minute. Please wait. Yes. See here. So this one is what? Pointer. This one is the pointer. This one is what? Pointer next. Pointer next. So to access this value, what we write? Pointer next next. So now what is the pointer next value? Null. So pointer, this one is the pointer. This one is what? Pointer next. Okay. So after this, no node is there. So we are holding null. So pointer next value is what? Null. So pointer next value null means we are removing last node. So if pointer next value null means we are removing last node. If after this one node is there, that node's address will be here. That node's address will be showed here. Means the pointer next value is not null. Means we are removing middle node. Pointer next value not null means we are removing middle node. If pointer next value is null means we are removing last node. So that condition I'm writing. So here I want to check whether we want to remove last node or not. For that we are writing pointer next. So pointer next value equals to null. Then we are removing last node. Okay. So now we want to remove last node. So this is the last node. We are removing it. So now this one is what? Pointer. Okay. So now make this pointer next as the null. Make this pointer next as the null. So here store the value null. Means this link will be deleted. This link will be deleted. No? Okay. So pointer next value will become null. Okay. So for that, what we write? Pointer next equals to null. Okay. So before that, assume that as the temp. So assume the node which we want to remove as the temp. So the node which we want to remove, assume this as the temp. So we want to remove pointer next. So assume this as the temp. So temp equals to pointer next. So here write temp equals to pointer next. Okay. After that, make pointer next value as null. Make pointer next value as null. Pointer next value as null. Okay. So because after this, no node is there. We are removing last node means after this, no node is there. So make pointer next value as null. So right here, pointer next equals to null. Okay. Then now make this pointer as the last node. Last node removed means this last but one node, pointer node should become the last now. So make this pointer node as the last. Make this pointer as the last node. So make this pointer as the last node. So for that we write last equals to pointer. So right here, last equals to pointer. That's it. So this is the code for removing last node. There's a code for removing last node. Else, else. So when it comes to this else part, when this condition is false. So this condition p equals to 1 false means we are not deleting first node. This condition false means we are not removing last node. So we are not removing first node, we are not removing last node means we are deleting the middle node. Okay, so that comes to this else part. Okay, when we try to delete the middle node, this condition false means we are not trying to delete the last node. So that comes to the else part, we are trying to delete the middle node. Okay, so how can we delete the middle node? So removing the middle nodes, removing the middle nodes. So to remove the middle nodes, total 5 nodes are there. So we call like this, we call like L1 dot remove. I want to remove the fourth node. So right, 4. So fourth node will be removed. Or I want to remove third node, L1 dot remove of 3. Or I want to remove second node. All these are the middle nodes. Second, third, fourth are the middle nodes. Okay. So L1 dot remove of 4. We are passing. Okay. So now what is the p value now? P value is 4. What is the p value? P value is, we are passing p value as 4. P value is 4 now. Observe. So p value 4 means 4 equals to 1. Condition false, it comes to the else part. So now first becomes the pointer. So okay, so now position value is 4. Position value is 4 means 4 minus 2 times it will get executed. 4 minus 2 means 2. 2 times this code will get executed. So 2 times the pointer next will become the pointer. Okay, I'm taking the fresh file here. I'm taking the fresh file now. Just a minute. I'm opening the file. See here. So we are assuming first one as the pointer. Okay, pointer next will become pointer for 2 times. Okay, so next time pointer next will become pointer. This pointer next will become pointer. We are giving position value as 4. Means we are coming up to the third position. Now this one is the pointer. So this one pointer means this one is not pointer and this one is not pointer. This one is the pointer. Okay, we want to remove this position 4 node now. So we have to establish a relationship. So assume this pointer next as the temp. So this is pointer. We want to remove this one. So we want to remove this one. We want to remove, we want to remove fourth positions node. Means this node we want to remove now. This node we want to remove. Okay. So assume this as the temp. Assume this as the temp. So what we had write? Temp equals to pointer next. Okay. See that code already we are writing in the if first statement, and in the else also first statement is temp equals to pointer next. So I'm writing this statement here because in the if or in the else first statement is this one only. So pointer next will become the temp now. So now this one is the pointer. This is pointer next. Pointer next we are assuming as a temp. Okay, just a minute. So this one is the temp now. Later it will be removed. We are using delete. After else part we are writing delete here. So delete temp, so that will be removed. This node will be removed. So we have to establish the links like this now. Observe carefully. Observe carefully here. So now we have to establish a link like this. We have to establish a link like this because we are removing that node means we have to establish a link like this. So now this one is pointer. This one is pointer next. This one is what? Pointer next next. This one is pointer. This one is pointer next. This one is what? Pointer next next. So make pointer next next as the pointers next. Okay. So here this one is the pointer next. To access this location, we write pointer next. Here we want to store this pointer next next address. Okay, so here we want to store pointer next to next address. So what we have to write? Pointer next equals to pointer next next. Pointer next equals to pointer next next. That's it. So right here, pointer next equals to pointer next equals to pointer next next. Okay, so now this one is becoming the pointer next now. Now this one is a pointer. This one is becoming the pointer next now. Observe carefully here. Already we established the link. So now this one is the pointer next now. Okay, now we have to establish a link like this. We have to establish a link like this. We have to establish this link. Means here we want to hold this pointer's address. Where in the pointer next, this is pointer. We already made this as a pointer next. In the pointer next to previous, here I want to hold this pointer address. So here to access this, what we write? This one is the previous, right? Previous. Okay, in the pointer next to previous, in the pointer next to previous, I want to store pointer's address. So write pointer next to previous equals to pointer. Pointer next to previous equals to pointer. So here it stores pointer's address. So pointer is becoming pointer next to previous node. Okay. So write pointer next to previous equals to pointer. Pointer next previous equals to pointer. That's it. Over. Okay. Now observe. We established that blue link and brown link means this node will be deleted. So delete temp means this node will be deleted. Okay. So now this node will be deleted. This node will be deleted. Means link is there. Okay. Hence we can delete the node. Okay. So this is the code. This is the code for deleting the node. Okay. Very simple. In the insertion, in the linear single link list also we did this program. But here we are maintaining previous node's address also. That is the only difference. Okay. For clear understanding purpose, okay, every time I am explaining every point. Okay. So this is about deleting a node from double linked list. Now see, I'm showing the code. I'm executing the program now. So defining remove method is over. Okay, now I'm calling. Here linked list created. Linked list has how many nodes? 5 nodes. We are printing the elements here. So 10, 20, 30, 40, 50 will be printed. I want to remove first node. Okay, so to remove first node, I'm calling the method remove method here. I'm calling the method remove method. Just a minute. That is not showing remove. So here we didn't write return type. Write return type as white. Okay. Now L1 dot remove. See, remove method I'm calling. L1 dot remove. I'm giving position value as 1. So first node we are removing. After removing the first node, I'm printing the elements. I'm printing the elements. Observe, I'm pressing F11. See the output. So now first node 10 will be removed. See here, 10 is not there. 10 removed here. That is printing 10, 20, 30, 40, 50. 10 removed here. Okay, 20 became the first node. See, here we are printing from last to first. 50, 40, 30, 20. So 10 removed here. Okay, first node removed. I am giving position value as 5. So 50 will be removed. Observe, 50 will be removed. See here, there is no 50. Okay, so before removing 50 node was there, last node. But now 50 is not there. Here we are printing from last to first. 40 became the last node. 50 removed. So we are removing the last node here. Next, I am giving position value as 4. Middle node we are removing. So 4 means 40 will be removed. Observe, 40 is not there. Observe, after 30, 50 is there. 40 is not there. Here also, it is printing from last to first. So 40 is not there. Okay, so middle node removed. So these are the 3 cases. Okay, so now I'm stopping the session here. Okay, just today we learned how can we delete the node from the linear double linked list. In the next session, I explain how can we modify the element of the linear double linked list. Okay, if time is there, I also explain about how can we create the circular double linked list. Okay, after that, I explain some theory points. So with that, this linked list topic will be over. So within 2 sessions, I try to finish the linked list topic. Okay, I'm stopping the session here.